Yes, class, am I audible to all of you? Yasir, Harsha, Martin.
Yes, ma'am.
Harsha? Okay. Martin's again audio is not connected. See, in the last class, we had started conservation of energy. So kinetic energy was equal to potential energy. This we had seen. All the kinetic energy becomes equal to potential energy. So initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. So change in kinetic energy is equal to change in potential energy. One small proof, see, change in potential energy is negative of work done, right? When we talk about the regarding the internal forces. So work done is what? It is negative of potential energy. What is work done equal to? Work done is equal to change in kinetic energy according to work energy theorem. So this is equal to change in potential energy. Bring this here. So change in kinetic energy plus change in potential energy is zero. This won't come in your exam to prove, just for your sake. One question, let us practice. Just note down this part and this question, then we discuss it. C class, this is an important question. This comes as a proof in your exam. You have to prove that total energy of a freely falling body is conserved. So mass, a body is there at initial point A is there, you have dropped the body. So initial point is A, final point is B. Now mass of the body is M, the body has covered H displacement. So you have to prove that total energy is constant. So questions can come in different form, the same question. It can be asked to you, what is proof conservation of energy. That time also you have to show this question only, but it will mention you freely falling bodies case, then only you have to show this. For other, you have to show just kinetic energy is equal to potential energy. All right, now see, at point A, when we talk about at point A, see, mass is M, acceleration due to gravity is g, and displacement that has been covered is h. So what is your potential energy? You have the potential energy, change in potential energy at A point is mgh. Fine. Now change in kinetic energy at A point. See, this is the highest most point, topmost point. You have started dropping the body right now. So initially the body is at rest when you are dropping. So kinetic energy would be 0. Now, coming to this downwards B point. So yes, what is the total energy? Total energy zero plus mgh, which is equal to mgh. Now come to B point. Change in potential energy. Now see, force is mg. What is the displacement? When it is back on the ground, from the 0 reference we take that separation. No, it is exactly 0 because it is on the baseline only. So this is 0. So height, since height is 0, that's why mg into 0. All right. Now, what about kinetic energy? Change in kinetic energy. This is half mvb square. Now, this time velocity won't be 0 because it is having a final velocity. Initially, it was at rest when we had dropped it. But now when it is coming back, this is vb will be equal to, let's write down the formula. V square minus u square is equal to 2as. Why am I using this equation? Because in the other two equations, no, v is equal to u plus at and s is equal to ut plus half at square. Time is involved. Now, what are all quantities which are mentioned? See, final velocity is vb, which we do not know. Initial velocity is 0. 2 is a constant. Acceleration is acceleration due to gravity because it's a freely falling case. And displacement covered is minus h. Why am I taking minus? Because remember, we did this in motion under gravity. I am considering downwards as negative and upwards as positive according to the sign convention which I have chosen. Now let us put all this value in this so that we get the value of b. I require the value of b. So vb square is equal to 2gh. That's it. Now what is kinetic energy? Change in kinetic energy is half mvb square. Means you have to put the term as it is. That becomes half m into 2gh. This gets cancelled, right? So what is the total energy at B point? 0 plus again you are having mgh because this is equal to mgh. So you can see energy at A point is equal to energy at B point. Hence, total energy is conserved. This is a special case of a freely falling body. Note it down. All those who have joined late, this is the question.
Ma'am, even if we change the sign convention, it will be the same, right?
Yes, Harsha?
Ma'am, even if we change the sign convention, it would be the same, right?
It would be the same. It would be the same. If you change the sign convention, both will be plus plus.
Okay, ma'am.
Is it on conserved?
Yes, Martin?
It's been conserved, right?
What?
Ma'am, show that the total energy of a free falling body is conserved, right?
Yes, yes, yes. You have to show that total energy of freely falling body, this is conserved, right? See, I have taken downwards as negative. The ball is coming down, so displacement is down, and acceleration due to gravity also acts downwards. So G is also downwards. That's why I've taken both as negative. You can reverse the sign convention. You can make this upwards as downwards as positive. So both will be positive. You will get the same answer.
Okay.
Done. Completed or still writing?
Done, ma'am.
What about others? Martin, Abdullah,
Yeah, ma'am, done.
Abdullah, Abdullah, you have stopped answering. You have stopped responding in the class. Okay, next topic, power. See, we have studied energy. Work done we have studied, then related to work done we had a concept of energy. So altogether this work done, you have to focus on work done only. Work done and energy, that can be interrelated. Whatever is the rate of change of doing work means change in work done with respect to time. In 1 second I'm doing 5 joule of work. In the next second I'm doing 10 joules of work. Then again in the next second I'm doing back to 5 joules of work. So this rate of change, whatever is the change that is occurring, this is what we call, give the term as power. You can use the term work done also, you can use the term energy also. Whatever is the rate of change of energy per unit time, whatever energy has been changed over a period of time. So if I say rate, always remember this, I have mentioned earlier also, keep this in mind. Whenever the term gradient is used, then something gets divided by position. Okay, if gradient is used. If rate is used, if we use the term rate, so for rates, when I say rate of doing work, that means change with respect to time. So gradient we have for change with respect to position, and rate we have change with respect to time. This is the difference which you have to remember. So power is what? Power is equal to work done per unit time. It's also scalar quantity. I've told you in this entire lesson is based on all the scalar quantities. Now see, this is work done SI unit is joules times SI unit is seconds. So we use joules per second, but we have a proper SI unit. This is 1 joules per second is equal to 1 watt. All right, this is 1 joules per second is equal to 1 watt. Now, similar to what we have been studying earlier also, in your motion in a straight line, what did we study? Rate of change of displacement means displacement divided by time gave you velocity, right? Rate of change of velocity, velocity divided by time gave you acceleration. So there was one thing common whenever we had to calculate. If duration was given 2 to 4 seconds, 4 to 2 seconds, 8 to 10 seconds, like this, if you have a particular duration, then what do? We take the average. How do you take the average? Change in the quantity divided by the duration. So change in work done by change in time. How do you calculate change in work done? Final work done minus initial work done. So average power, how do we calculate this? Average power is calculated change in work done by change in time. How will you calculate change in time? That is change in duration. This is final work done minus initial work done. This is final time minus initial time. If you have a time instant, at a particular time instant, you have to calculate. Then average power, this will be differentiation. You will differentiate it simply. This becomes dW over dt. This is differentiation. So instant means at a very particular time instant, I'm telling you, at 3 seconds, at 0.04 seconds, at 3 p.m. like this, a very particular time instant, then you differentiate it. One more formula of power we use other than work done divided by time. One formula is this, you will be using work done divided by time. This is it. This formula will be there. One more formula you have, and a very small derivation it has. See, power is equal to rate of change of work done. Power is equal to rate of change of work. And what is work done further equal to? Force into displacement F dot ds. So how, if we substitute this value here, what will power be equal to? df dot ds over dt. Fine, not df, f dot ds over dt. See, if f is constant, this will come out. If force is constant, then if this is the condition, then you can take out power force can be constant, right? So power is equal to force ds over dt. Here this ds was what? This was displacement. Displacement. And t is what? T is time. So what should be this quantity? ds over dt.
Velocity.
It would be velocity. Only Harsha is active in the class. It ds over dt is what? This is velocity. So we no, velocity is what? Rate of change of displacement. So how can you write? Your final answer will be power is equal to F dot V. Force multiplied by velocity. V is what? V is velocity. F is force. V is power. Note it down. Then let's see, sir. Very few questions you have from power. Power is a very small section. This is the theory. This is it. No other theory is present. Power is a very small topic. Note down this. See, this question says force is 10 Newton, velocity is 5 meter per second. You have to calculate the power. So power is equal to force into velocity, 5 into 10, that is 50 joules per second, or you can write 50 watt.
Ma'am, is it F dot P, like dot product?
Force multiplied to velocity, yes.
Okay.
Yes, class, share the answer of this question. Calculate power spent by energy. Slope, this says a body of mass 100 kg is moving up an inclined plane. So this is moving up with velocity 10 meter per second, slope 1 in 5. Slope 1 in 5, calculate power spent by energy. Slope 1 in 5 means what? This means sine theta. Sine theta's value is given 1 divided by 5. Slope 1 is in 5 means sine theta is 1 by 5. Now solve it. Apply the concepts of laws of motion. Let me know this answer. All of you should answer in the chat column.
Ma'am, what does slope 1 and 5 mean?
Slope 1 in sine theta means, see, 1 in 5. This 1 means this is your perpendicular, 5 means your hypotenuse. So whenever slope 1 in 5 is written, so make the first digit as the numerator, second digit as denominator. Most of the questions, not in your, usually in the exam this is avoided, but in your reference books also, and somewhere in the papers also I have seen slope 1 in 5 is written. So the sine theta 1 by 5 you will be requiring this because theta's value is not given. So direct sine theta's value is given. Now you have sine theta's value, you know perpendicular. Let me tell you this class, just pay attention to here, then you can solve this question. This is perpendicular, this is hypotenuse. So it means perpendicular's value is 1, hypotenuse value is 5, 1 unit and 5 units. From here, you can find out the value of base using Pythagoras theorem. Once you know P, H, B, all three, you can find sine theta, you can find cos theta, you can find tan theta all. Using this P, H, B, use your Pythagoras theorem. Then using that, you can find out tan theta also, you can find out cos theta also, whichever values are given. So have this trick whenever 1 and 5 is given, that means it is perpendicular and hypotenuse mentioned. Now let me know what's the answer. No, Harsha. See, velocity you won't resolve. Look at it. You have to resolve the forces. What all forces are acting? Mg is acting downwards. Normal reaction is acting, but normal reaction isn't required right now. Velocity is acting in this plane, that is 10 meter per second. Mg is acting downwards. You have to resolve this force because we want to find the force which is acting along velocity. Which is the force? No, that is making it move. And this force, this becomes mg. This is mg cos theta, and this is mg sine theta. This is resolution of vectors. What is the power? Power is equal to F dot V. Now force is, we didn't know the force, no? That's why we had to resolve and check it. Now we know the force that is providing the motion. This is mg sine theta. So mg mass is 100, acceleration due to gravity 10, sine theta itself is given. So no need to remember any other value in this question. 1 in 5. Understand this 1 in 5 very clearly. 2000. Very good, Alia. Correct answer. 2000 watt. Mention the units. 1 in 5. So 1 is perpendicular. This is hypotenuse. Find out base also. Find out cos theta, tan theta.
And sine 90, right? Sine 90.
90? Why?
The angle is 90.
Sine theta's value is given to you 1 by 5. Now log table you will check whatever is the value of sine as 1 over 5. That you will take it as theta, not 90. You know the 90 degrees value. Sine 90 you already know. It's 1. So how can it be 1 by 5, right? This is 1 by 5. So 5 gets cancelled. This becomes 200 Newton. This is just the force. Now force into velocity. Power is, force is 200, velocity is 10. So power becomes 2000 watt or 2 kilowatt. Write down the solution.
Ma'am, can you show the new diagram?
A question?
No, ma'am, the figure.
This one?
No, the figure. That.
Okay. Figure. So figure is there only. I will figure noted down. Figure and the question, even if you have missed it, write down the figure. Now we are left with collision. Collision comes under your work energy and power only because it is based on conservation of energy.
Ma'am, how do we decide which is cos theta and sin theta?
Yes.
Ma'am, how do we decide which is mg cos theta and which is mg sin theta?
Whenever it is written, no, 1 in 5. You are asking how to choose this cos theta or this one?
The axis one.
This one?
Yes.
This you are asking.
Yes.
See, why have we considered the force as this mg sine theta? Look here. Normal reaction, if it is there, mg cos theta, see, normal reaction would also be there. This is saying a body of mass 100 kg is moving up an inclined plane. Fine, this is moving up an inclined plane with velocity of 10 meter per second. So this is moving up 10 with velocity 2 meter per second. Now, what about the forces? What all forces can act? Frictional force can act. If we have normal reaction is acting upwards. and mg cos theta is acting here. So normal reaction and mg cos theta, they are balancing each other. One more force that could act was frictional force. But since no information regarding coefficient of friction was made, so we couldn't consider frictional force also. Last force that was left is mg sine theta. That's why. Because this is being balanced by normal reaction. And y-axis, this perpendicular to the plane, is now not of our use because we require that when we have friction. Because F is equal to mu n, that's why we need normal reaction, and this n is equal to mg cos theta. Right now, this is being already cancelled from normal reaction. So that's why this is only the leading force. Clear?
Okay. Ma'am, like, how do we decide which is cos theta and sin theta, like the theta part?
How do you decide cos theta and sin theta? If you are having theta, see this, you understand why this is theta.
No.
See, when we were doing laws of motion, that time I had told you this inclined plane. Just a second, class. See, this is theta. Let's say this is your mg. And here we want to know what is this, mg cos theta or mg sin theta. This is 90 degree. So what this will be? 90 minus theta. This entire is 90 degree. So 90 minus theta minus 90, that would again give you theta. So it's like this axis is mg, this is theta. Whenever we are resolving vectors in resolution of vectors, when we were studying vectors, this we had studied that the axis, the angle with which the axis is made, that is always termed as cos theta, and perpendicular to it is termed as sin theta. So mg cos theta, this is how you decide, and mg sin theta, this is how you decide. Now clear?
Yes.
Just revise resolution of vectors because they are very important. You will be requiring that. Now the last topic that is left is collision. So certain theory part of collision we have to discuss before going on to its numericals part. This is the last part, because this is related to conservation of energy, and everything will be related to conservation of energy in here only. See, collision means what? Collision means two objects are colliding, that's it. But what do we study in physics? Why are we considering it? First, you have to understand the meaning of the term isolated system. System word is what? We have discussed this in detail. System means the part that is under your consideration. So when I say the net force is zero, that means isolated system. Isolated system means the net force is zero. So isolated word can be used. That's why I'm mentioning this. Now see, it's like two objects, they are moving. One with velocity u1 as the initial velocity, second with initial velocity as u2. So m1 is the mass of the first body, this is having u1 as the initial velocity, and m2 is the mass of the second velocity, and this is having u2 as the initial velocity. Now both the objects are moving. So the speed of one of them will be greater than the other to collide. If both of them keep on moving with the same speed, they'll just move parallel to each other. They'll not collide. One has to move a bit faster. So by this, you can assume, you can know the fact that one velocity is greater than other. In every question, if collision has to occur, this is one condition. So when two objects are moving, one velocity exceeds and this collision occurs. Now, this is the case. This is the case before collision. This is the case before collision. U1, M1, U2, M2. This is the case before collision. Then they are colliding. During collision, the net force becomes zero because whatever force is being exerted by M1 is exactly being exerted by M2. So net force becomes zero. This is the case during collision. Then after collision, what happens? After collision, see, both the bodies now, it can happen, both can stop also. One can stop, one can move, both can be moving. So we assume the maximum case that both of them are moving. So now they were moving, they collided, and now they are moving with a different velocity. So now the velocity with which they are finally moving, that is your final velocity. Now see, if let's say I say the final velocity of M2 is zero, means M2 has stopped and V1 has started. If I say final velocity of V1 is zero, so it means they had collided, V1 stopped, M2 kept moving. If I say V1 and V2 both are zero, so after collision, both of them didn't have so much momentum. We studied momentum. They didn't have so much momentum because, you know, momentum is used here. M1, V1, M1 into V, mass into velocity is momentum. So if enough momentum is not present, so yes, collision is an isolated event in which large force acts on a body for a short duration of time. Force acting for a short duration of time, we had studied this impulsive forces. Remember, a graph also had drawn. A graph also you have seen where a sharp peak occurs, impulsive forces. So this results in changes in their velocities. All right. This results in changes in their velocity. And physical contact is not necessary. See, physical contact is not necessary means if two objects are moving, somehow their net force is zero, even though they are not colliding, they are not in contact with each other. Then also we can say collision is occurring. But this is a very rare case. For collision to occur, usually the objects have to be in contact. But if the net force is becoming zero and velocities are changing, so you can conclude the fact that physical contact is not necessary. Now, what are the types of collision you have? You have elastic collision, inelastic collision, both in one dimension also and two dimensions. One dimensions mean head-on collision. This is head-on collision. Means both the bodies are after collision moving in the same direction, in a straight line only, either like this or like this. Both are moving in a straight line. In oblique collision, when both the objects collide, one moves at a certain angle, like this. Collision occurred, or both of them were moving, collision occurred, this moved at a certain angle. That is 2D, oblique collision we also call it. Now, what is meant by elastic collision? What is meant by inelastic collision? These elastic and elastic, we'll do this in detail. But before that, just have a brief view of it, because without that, you'll not be able to understand. Elastic collision, all the conservative forces come. Electrostatic forces, gravitational forces, tension, these will come. In elastic, non-conservative forces will occur, like your friction force, viscous force, all the dissipative forces which produce heat in your system. So because of which, if heat is produced, energy will be lost. So there is loss of energy and heat in inelastic, but there is no loss of energy in, there is not loss of energy, there is no loss of energy in elastic. This is a very important point regarding potential energy and kinetic energy that differentiates. This is actually the main point. Potential energy and kinetic energy are conserved. Here, kinetic energy is not conserved. Just momentum remains conserved. Potential energy and kinetic energy are conserved. Both are conserved in elastic. But kinetic energy is not conserved. Means if you have a situation where non-conservative forces are present, friction is present, or the question is mentioning you that inelastic collision is occurring, then do not use final kinetic energy is equal to initial kinetic energy. This you will see through questions, because we'll be practicing a lot. We'll be practicing questions where conservation of energy is involved, but potential energy remains constant. Last thing is total energy also remains constant in elastic. Momentum remains conserved in inelastic. So momentum and potential energy are conserved here. In your elastic, potential energy, momentum, kinetic energy, total energy, all are conserved. Whereas in your inelastic, kinetic energy is not conserved, rest are conserved. So this is the introduction theory part of collision. All these points are important. Start noting it from here.
Can you go back? Now can you go back? Yeah.
Completed till here? Just text me done once you have completed. Okay, if you all have completed, you can leave. Please attempt your after class assessment. Now we'll complete this in the next class, collision.
Thank you, ma'am.
Yeah, thank you.